Good morning, everyone. I think it's time to get started, and this mic shows it's 10:15, so we want to start precisely and use more time talking about data warehousing in the cloud. My name is Alexei. I'm coming from the customer advisory team. I used to be in the SQL customer advisory team, if someone familiar with this group, who has heard of the SQL cat in the past. Wow, a bunch of people, thanks a lot, guys. Then there was a number of reworks. We landed in the Windows Azure team, but I'm still taking care of the databases and BI solutions. And the biggest hype at the moment in the market we hear is the cloud technologies, how to get in the cloud, what the benefits of the cloud. A lot of excitement, but at the same time a lot of concern. Who of you, let's do some physical exercises early in the morning, right? So like if you know the answer, raise your hand. Who of you heard of the cloud technologies and who is using them in their day-to-day basis already? Oh, quite a bunch of people, I was not expecting that. Is it something to do, like, raise your hand if it has something to do with databases. Wow, that's awesome. Good. So who of you work on a day-to-day basis with any kind of the data warehousing? Wow, I like it, really good crowd. Now, very difficult question. If your database or data warehouse is bigger than 1 terabyte, raise your hand, please. Quite a bunch of people. Bigger than 5 terabyte? You see, the discrepancy is pretty much big, right? It's about 1 to 2/3, right? And so, who has dealt with data warehouses bigger than 10 terabytes? Just like about 10 people. And this is what I wanted to start with. Speaking about data warehouses, a lot of the kind of data warehouse is extreme workload. We all know it, right? And speaking about that, a lot of people get concerned where the cloud technology can really support it. Because cloud technology, it's not surprises, it's a multi-tenant environment where you don't have dedicated hardware, which you have typically in your infrastructure. You really like it, right? You can control it. And instead, a lot of people get concerned about how will this very sensitive workload perform in the cloud. So when we, in the past of the SQL cat, or actually even now, when we dealt with the large projects, like bigger than 10 terabytes, I dealt with a couple of projects where we built data warehouses about the range of 100 terabyte and bigger. What we used to talk about is what it always required high-end hardware. Many vendors have kind of formalized it in the way of the appliances. We have parallel data warehouse. Oracle has their own version, Teradata and Netezza. So it's all very complicated, very like specifically designed for the data warehousing hardware. And it also, well, alone buying this hardware is not enough. There are religious wars, you know, about like talking about schema, like whether you follow Kimball model or whether you follow Inman model. We'll not dig into this type of discussions, but what it is all about, there are thoughts above the architectural level, hardware architectural level, on how to optimize your workload and in order to let the data warehouse perform better. So, and of course, the range, as I told you, was like bigger than 10 terabytes, pretty much scalable solutions. In reality, if you look at the distribution, it was my assumption, I was really surprised from one side and happy from another side to see, to find the confirmation of it. If you look at the distribution of how many people in the world dealing with data warehouses bigger than 10 terabytes, it's pretty much small number of people. Majority, I would say like it's about 80%, still working in the areas under 1 terabyte, and they haven't crossed this limit. So usually, if you talk to these customers, it's you deal with the data warehouses on the departmental level, pretty much small hardware. Sometimes it's even virtualized. This is what we were not recommending. We were saying, like, if you work with a data warehouse, make sure you work with dedicated hardware, blah, blah, blah. Now they put like a virtual machine with 4 cores and some disk there, and they're pretty much okay. And their data warehouse is the size like 100, 200 gigabytes. serving, I don't know, HR department needs or accounting department needs, that's fine. And therefore, the SLAs for these data warehouses are different. We are not talking about moving data over like hundreds and thousands of gigabytes per day into this data warehouse and back and building very comprehensive reports. They've been dealing like, I don't know, with 1-2 gigabytes a day updates, if at all. So if the database of the HR department is dead, who is worried about that? Nobody really, right? If it's online next day, that's fine. If HR is not working, what they typically do, so then everyone is okay as well. And separately, as a parallel stream, what we recognize, more and more people getting taste of analyzing data which are not existing in their internal business processes or internal infrastructure. They are getting this data from outside world. Like the famous example, what Microsoft typically shows on the all BI related sessions is like Twitter analysis or Facebook analysis. Some people find it useful, like marketing department might get excited knowing what a lot of people tweet about their products. I don't know really about the value of it, like if it has some meaning or not. But it means for us as DBAs or the architects, what we are talking about merging external data into your data warehouse environment. So it's very often not structured data, like Twitter, it's hard to structure it, or like statistics from the web clicks, it comes in the form of the XML files often, so you need to also kind of bring it into relational form before you'll be able to analyze it. And very often, all of this data, they live in some form of the cloud, right? So it's like publicly available source which you can connect to, you can suck the data out of there and then use in your data warehouse environment. So with bringing all this stuff together, what we as a Microsoft thought, we have actually two platforms. We've got released IS VMs, so SQL virtual machines in the cloud, which are scalable up to, like if you consider all the possible options, you can grow up to 16 terabytes. Or PaaS, Platform as a Service offering, which is SQL Azure database. So this is an environment where you get database without all the possibilities to control it, but it's simplified version of dealing with your data which you want to store in the form of tables or whatever. So all this already closer to this external data because it is a cloud. So cloud is closer to the other cloud rather than to your infrastructure. The good thing about all this stuff is, at least how we sell it, right? It gives you ability to reduce amount of the administrative overhead, because if you use like PaaS offering, like SQL Azure database, you don't deal with patching of this stuff, you don't deal with kind of controlling which disk performing at which speed, and then how to perform file allocations and manage all the TempDB and the stuff. It's done by Microsoft for you, right? And or by some other cloud vendor. And the only stuff what you will be dealing with is maybe optimizing your tables, like building clustered indices or additional indices and loading data, making backup, but that's it. So you're limited to the surface of the table level or database level. And interestingly enough, looking at both these options, you immediately see what the initial cost of getting this stuff available for you is, and speed actually, is way lower if you compare it to the on-premise solutions. What I'm saying here about, if you want to build a data warehouse to play with some model, right, and build some reports, typically the process, you go to your manager, you ask for hardware, he requests the money from his management, this gets approved or denied, then another round starts if you're not lucky, so you need to justify why you need this hardware. Finally, the purchase order is placed, the hardware will be sent to you within months or two. We've got someone sometimes delays like for 3-6 months getting hardware, and then when once you get your hardware, it's about half a year past, right? And then you can start play. In the Azure, you have your subscription, you go, you dedicate your VM, for example, right? You attach your disk, and half an hour, you're ready to go. You can start playing with this. So this can be pretty much attractive options for you. And we found, we thought we have best practices for data warehouses. We've got VMs. Why not to look at what we did for the fast track reference architecture guide and repeat the same experience in the cloud? So we've been inspired by this idea and took the high memory VMs. The only agreement that we made, let's talk about under 1 terabyte data warehouses. This is related to how much of the virtual disk you can connect to the machines. Basically, the raw idea was to, and I will be talking about that, basically get one core associated with one disk drive, so to get more or less balanced performance between the CPU and the disk IOs. Right, so this became available, like published about a month ago. We have the white paper, which consists of the description of how you can build that or deploy in the cloud, as well as a PowerShell script, which you may need to run in order to set up this environment if you prefer programmatical approach. So the link is available. You can click on it once you get slides shared. Now, there are two options how you build this stuff. Actually, I can show it on Windows Azure, but if you're familiar with Windows Azure, you may recognize where it's coming from. You go to the Windows Azure gallery. I'll try to see if I can quickly show you where it is. So, you still see my slides. So if you go to the Windows Azure, you go to the gallery and you can choose one of those options. Curious why I'm not seeing my, here we go. How is the resolution? You don't see half of it, right? So you basically say create new machine, create from gallery. And here you have two options. CTP2 evaluation for data warehousing, CTP2 of SQL Server 2014, and there is somewhere also the version based on SQL Server 2012. I don't want to scroll back and forth, but believe me, this option is there. And so let's say we select the 2014 version. It has explanation on the right side, what it is about, blah blah. I really like the resolution here. I cannot do anything. Okay, so let's not waste the time and go to this session and back. So your menu will switch to the slide where, or to the window where you can choose either size of A6 and A7. The difference between this A's is how many cores you get associated or provisioned for you once you choose this VM, and it could be either 4 or 8 cores. So the thing here is that Microsoft constantly develops different possibilities for you, which VM sizes you can get, right? So therefore, don't get frustrated if you want to see like 16 or 32, it will come in the future. But the most important thing, if you compare it with other VMs, there's also XL and L, so which have correspondingly 4 and 8 cores as well. Those VMs have much less memory than those A type of the VMs. One has 56 gigabyte of RAM and another has 28 gigabyte of RAM. So as I told you, you can choose either to deploy the VM through the gallery. Once you choose the gallery, you can see automatically what you will have all the kind of steps done behind the scenes for you, like attaching disk, dedicating disk, and etc. Or you can go and download the PowerShell script. In the PowerShell script, you will have flexibility to specify the variables yourself, like what the VM name you want to use, or data warehouse you want to use, the number of disks you want to attach, and etc. It really depends on which situation you're in, and if the programmatic approach serves you better, or you just can go with the wizard. not much different because behind the scenes is the same code base running. Now, if you look at Azure Data Warehouse under the hood, how this stuff is actually architected, you will see some differences with what you used to see on premises, and those are important points to understand, because you will understand how the stuff actually lives and why it performs differently to your on-premise configuration. Before we look into go into depth level, talking about VM and how does it impact performance, we need to refresh the thinking what we usually have in the data warehouse lifecycle. Because when you start, you typically start with thinking about the architecture, right? You're thinking about model, what you want to build, type of reports you want to serve, and then it actually impacts the way you create your database. So creating database is a step that you can't avoid, right? Then the next step is thinking about is the connectivity. So how the application will connect to your data warehouse, how many connections you will have, how you scale all this stuff. And then another important point is actually the speed of how fast the data getting into your data warehouse. We're talking about two situations, major different situations here. First, initial data loading, because it's seldom when you create empty data warehouse and it starts naturally growing. Typically, you're moving data out of somewhere into your environment, and then it switches in like normal production time. It can be backup restore as well, so you need to plan what happens to your data warehouse in case of total failure or disaster. And of course, since some of you may need to deal with a big amount of data, you will think about stuff like compression. All this has impact on how you design the model and how you architect your database as well. And of course, not the last thing, what you worried about, how fast your reports will be running. So we will be looking at all the implications of this in this session, so in consideration of the Azure VMs. If we talk about the architecture, I don't know, as I was writing the slide, the old kindergarten anecdote was always popping up in my mind. You remember the story when the God collects all the creatures on the earth and says, like, guys, you know what? I need to split you all into big parts. The beauty ones go on the left, and the clever ones go on the right. So and the crowd starts like flowing into two different directions, unless one only monkey stays in the middle. And the God asks her, like, what's the problem with you? And she says, like, you know, I cannot decide which side I have to go. And the same for the database architect, or actually data warehouse architect. Once you build your data warehouse, you always need to satisfy two requirements. You need to satisfy the beauty and the cleverness of yourself, right? So you need to think about how fast you can load data, get the data in the data warehouse, and from another side, how this can impact your query performance. Because you want to have, it's either or. Either you focus completely on the high-performance queries, then you sacrifice the data loading speed. Or you say, I get the fastest data loading options ever, because I think about like real-time data warehousing or whatever, this can significantly impact your query performance. In general, in this situation, nothing has changed since, I don't know, SQL Server 2000 or whatever. We published a long time ago the document called Data Loading Performance Guide. Guys, don't invent the wheel. Go read this document. The same best practices which published there, they're still relevant. So the stuff like talking about minimal logging. Minimal logging has significant impact on the I/O operations once you load the data. Thinking about scaling the loading streams. Like with one stream, you're limited to the speed of this single driver or single I/O operation to the disk, right? So if you want to scale, you need to use more of them, right? So now let's talk about what's the difference between Windows Azure virtual machine and your on-premise machine. First of all, your virtual machine is getting hosted on the larger box with more cores compared to what you're trying to provision on this box. So typically like 32 cores around that. And we talk about host operating system and the guest operating system. Host operating system is the physical box, guest operating system is your VM. So communication between the other components, like network card, for example, and the data disk, going through the virtualization layer or hypervisor layer, right? And both network card and the disk, actually data disk and the virtual VM, are going through the network interface card. So you can think of the data disk in case of the Azure VM as a network attached storage. But instead of the physical disk, what you can have like in the shelf, right? In the Azure infrastructure, you go over the public recall infrastructure of the Azure configuration, and then you'll be connected to the blobs. What the blob is an entity which in fact consists from multiple disks and some high availability configuration between them. So you have tripled redundancy. So every time you write to the disk, it will be copied 3 times to another disk for the case that if one disk fails, your data will be still available, right? And sometimes you may have an option to geo-replicate your data to another data center. So if one data center, like nuclear bomb exploded there, data center is not available, the another geographically remote data center will be still having your copy of data. So this is all great, but this all increases the latency first. So all this network traffic, it costs time. Now, second stuff, the virtualization layer has also its limits. It's getting better. Actually, I was so happy to see what the performance what we saw for about like 9 months ago as we started working on the IS, and now it's nearly doubled, right? So, and we are constantly talking to the product group. They're improving the configurations there, but what you need to understand, the bottleneck is the virtualization anyway. You are not getting as fast disk access as on your on-premise configuration. Right, so, and this layer is actually the driver. It has a performance limitation now around about like 200, 250 megabyte per second. You cannot scale above this number at the moment. In the future, I'm really confident that it will get higher. You have more options to tweak it, but this is something what you can expect from your storage at the moment. So, with saying that, your storage and on-premise configuration performance is totally different from the VM. What can also impact VM performance, by the way, don't forget you are in a multi-tenant environment. Means what is if as of a sudden many other database administrators decided to do clustered index rebuild or whatever, so what actually implies a lot of the I/O operations, so it will be all pushed over the network. So your network throughput will be impacted as well. So you're not getting dedicated network throughput. So therefore, the performance may vary here. One of the best practices what we figured out, actually, and we'll be talking about SQL.io and how to get realistic numbers from not realistic, but the better numbers from this management, from this tool. So one of the stuff what we are talking also about, like warming up the disk configuration. But before, first stuff, what I hope you kind of kept in your mind, I/O performance is different, right? Really, it can significantly impact some of the basic steps like creating database. One of the stuff what we saw, if like you create the database of a size like 300 gigabyte, it may take about 3 hours just to allocate the files. It's very long. There's a way how to work around it. You use the GP edit policy, so and you go and change the stuff. I'm not sure if you can see it. It's called perform volume maintenance task. It basically keeps constantly initializing files, and so you get different time which is required to allocate the files. Like it's for the same database size, it was like 40-45 minutes, about 3 times better, right? Another thing, same like in the fast track, don't rely on a single disk I/O throughput. spread it over the multiple disks, and so you get aggregated throughput. Because what typically we do in the data warehouse, we do big scan. So we go and scan a lot of data for the big report and suck the data out of disk. So if this scan happens across number of disks in parallel, you get, like in case if it's 4 disks, you get 4 times better throughput, right? And once you set up database, one of the things, it was actually best practice for on-premise as well, set up the size wisely. Do not create database if you think your production will be 100 gigabyte, do not create a database of the size 5 gigabyte and let it increment for 1%. Do it like 1 megabyte, like using defaults. Create 100 gigabyte big database, let the increment be about like 10 gigabytes, because each additional expansion costs you time. And this will be very visible on the performance of your inserting data and reading data out of there. Now, 2 options how you can scale. So when we built Fast Track a reference architecture guide, this option was not available. It's called now Windows Storage Spaces. And the like simplified version of what you see, it's kind of Windows Triton. But we do not recommend using RAID, software RAID technologies, or it's called operating systems Triton. Use Windows Storage Spaces. And I really recommend it for the log drive performance. I will show you the numbers why. Alternative to it, and why this is alternative, we spoke with many teams who are actually responsible for like making complete story, whether Windows Storage Spaces supported in the cloud. Technically working, it works. We still haven't got like full picture what the teams say, whether we'll stay behind it if I go with this in production or not. So it's not unsupported scenario, but we have no official statement yet whether if we run into problems, we will have corresponding reaction from the support PSS team, right? So, but I think it may change very soon, so you may want to consider this at least for the log drive option. And very classical one. You create your database, you spread your file group over multiple drives, and you'll be fine. This classical SQL Triton we call. Now, why Windows Storage Spaces is good? So what it creates is actually you have a number of physical disks. You can stripe your space across the number of disks. So what each of the stripe will be belonging to each individual disk, but all together you get aggregated throughput. And when we run SQL I/O for sequential read, imitating big report read, we saw what the difference between Windows Storage Spaces and SQL I/O Triton was not that significant, right? So therefore, for the data disk, you may decide which option is better. For example, Windows Storage Spaces may be better option if you have existing on-premise data warehouse with simple geometry, like sitting on one spindle, right? And you want to leverage more disk in the cloud, but you need to kind of imitate the single spindle, so Storage Spaces might be an option for you. Otherwise, if you just move the data using like ETL tools or whatever, you can, with the same success, use the SQL Triton. So for sequential read, it's not that big difference. What I wanted to show on this slide also, pay attention to the difference between single disk performance and the multiple disk performance. So I created 3 disks here. It's like 71 versus 160. You see it scales, and it scales pretty much good if you use a number of disks. For the log performance, it's totally different story. SQL striping is not helping for the log performance. Why? Because once you write to the log, you will be accessing one file at a time. So you cannot spread the throughput over the number of disks. Even if you dedicate 4 disks to the log, so like place a number of log files in different files, one file at a time will be accessed, which is not good because you get bound to the throughput like 75 megabytes per second. This is, by the way, the number which is close to the blob performance. So original, the blob what the data disk is relying on. So this is the number what you can You will not get higher at the moment, at least, right? So Windows storage spaces, though, since it's striped across a number of disks, can give you around like 167 megabytes per second, and this is what you see consistently. So that's why it scales with the number of disks. If you add more disks, the performance will scale even better, right? So for analog performance, it's really good option. Now, talking about connectivity, how you connect usually to your SQL database. You connect through the connection string, right? So in the Azure case, it's the same situation. You go and open on your dashboard particular port which you decided to use for connectivity, and this is cool. So you just point your application to the like HTTP mydatawarehouse.com port blah blah, and you get through. Or in some cases, what we saw, it is important, like especially for ETL cases, what you have VPN connection. So basically you join your machine into the network of your infrastructure. There are two options here, point to site and site to site option. Point to site is a kind of dedicated tunnel between your client server and your data warehouse server. Very easy to set up, really hard in case if you deal with the stuff like domain authentication and the stuff. For this option, site-to-site connectivity is better, but site-to-site connectivity requires some special hardware. So if you want to understand it better, look at the white paper in the MSDN. It describes it all in detail. I tell you, I just played with the point-to-site connectivity because like in the big infrastructure like Microsoft, asking for expanded domain to my private test environment is really pain in the neck, so it's not easy to achieve. So you may deal with the same situation, therefore I would say like if it's so complicated, point-to-site might save a lot of time and nerves for you. There are other options how you can move the data to your data warehouse, like we use the option for FTP. In some situations this is the only option. For some of the customers, we were not looking into this in this particular test. I did last year, I think, the session on that, talking about how to move data to the cloud data warehouse. So now finally we come into the data warehouse itself. So what we tested and how we tested. I took, like knowing usual workloads, I decided let's not invent the wheel. I took the TPCH database and created the schema, populated the data, and then the next step is how can I basically load it and see how fast it reacts. And there was no better option found. I use the HammerDB tool, which can simulate the random query out of all these 22 TPCH queries. So it picks the query and can run it the number of times what you specify, right? And basically I went through all the spectrum of the queries and I wanted to see what the throughput of this configuration, like whether I get acceptable performance or not. We should agree on one stuff. Once I say acceptable performance, so in a regular on-premise world, acceptable performance, people talk about milliseconds query performance, right? Or seconds, like Thomas showed yesterday's session where they were talking about 6 or 6 in second. This is multi-tenant environment, right? So that means what it will have significant impact on your query execution time. But for me, as an end user, if I see my report executing under 1 minute, I'm fine, right? So it's like you need to always to trade off between like having great query performance or paying cheaper for the infrastructure. Therefore, I made an assumption, okay, everything which runs under 1 minute is acceptable for me. If not, then we need to do something with that. So, first stuff, populating the database, how we tested it. There are a few options, copy backup to the data disk. So copy backup of your on-premise configuration and move the data into the cloud. Backup, restore to URL. This is the new option in SQL Server 2012 and 2014. And basically take your database and move your ETL target to the Azure database. So how fast can it work? I tell you, like comparing creating backup on-premise, moving the data over the wire, then restoring for the local VM disk is the slowest options ever. because disk performance is not optimal. It takes time to move gigabytes of data over the wire, and also it takes time to create database on your on-premise machine. If you do backup to URL and restore from the URL, this is the fastest option if you choose backup restore strategy. So the difference is with traditional backup restore is just what you say to device or whatever, you specify the URL path of your blob storage. Any questions on that so far? All clear? Now, when we talk about data loading overall, there are many factors what we are considering. First of all is, what is your SLA? I spoke with a couple of customers and they've been telling me, you know what, all this high-end and etc. transformations and data movement technology, this is not interesting for us because even if we move to Azure, we are still using batching approach. Means during the day, they use database for creating reports. During the night, they load the data. But this situation may vary. There are otherwise, in opposite, there are customers who are saying like, oh, I want to have little database, but have my internet traffic get stock, for example, ratio, whatever, quickly reflected in my database. So what are the options? So you need to understand how fast can you load the data. And this may help you with the decision whether the data warehouse in the cloud is an option for you or not. You need to think about tooling what you use for that. Because we tested different spectrum of the data movement tools. I tell you, BCP was the best, fastest option for moving the data. But if we talk about Azure, what do you do if you lose connectivity to your database? Because you need to go over the public infrastructure, right? It's not belonging to you. If a network provider decided to plug the trigger, right, and shut down the entire infrastructure, how do you make sure what next time when they're online, you can keep moving your data? SSIS, in comparison to BCP, is close. It's not as performance as BCP, but it's close, right? In SSIS, you can implement such a thing like, for example, retry logic. If connection get lost, you can catch this error and reinitiate connection once it's back again. Now, if you talk about data loading, you also talk about indexing. It's very often, if you've been to the browser session yesterday, often you see customers creating like 15, 20 indices to satisfy different queries on their table. Each index impacts loading performance. Sometimes you even get in a situation with the deadlocks, right? Once you start loading data and a couple of indexes trying to lock different trees there, so you may experience very bad single stream loading into database. So you need to think about whether you can live with less indices to satisfy most of the query performance, but from another side not to lose too much of the data loading speed. Compression has always significant impact on the data loading in any environment. Because compression, when you compress data, you reduce number of I/O operations because the data what you will persist will be smaller, but you move the load on the CPU. If your CPU bound, you have a problem, right? So you also need to consider that when you talk about data loading. Nothing new here. A lot of stuff was refreshed and published as a reference called like SSIS for hybrid data movement and SSIS performance and operational guide. We published it last year, I think. Right? The short summary for you to keep in mind, if you move data into the cloud, on-premise, we typically do the biggest batch possible, like 200,000 rows or 500,000 rows. For the public network, it is really bad. So therefore, the best performance what we figured out for our workloads was around 10-15K. You may try to play with your data, but believe me, you will need to significantly reduce size of the patches what you use in typical ETL. Retry logic. So once you get throttled means what your connection will be refused by the receiving side for whatever reason. So maybe you generated too many connections or whatever, and the system will suspect that you're trying to DDoS the system, right? So it can throttle your connection. You need to retry after some time, or if your connection gets lost. Implement this logic. We have examples on the Codeplex how you can do it. Another thing what you have to keep in mind, always network latency is very high. In the on-premise configuration, we are not really talking much about network latency. Here, since you need to go over the public connection, the latency will be higher. Therefore, importance of loading in parallel here increases several times as well. With one single stream, you will not achieve good performance. Forget about that. It's just not possible. Now, so it's all theory. What we do once we go to practice, we need to understand how fast our ETL or data movement works. So the best practice really, guys, try to understand what you're dealing with. Like for example, if we read data out of the other VM, let's say in the Azure, so the data will be stored on the data disk. Data disk is a blob, right? So therefore, if we talk about reading data out of the flat file, we're talking about around about 60 megabytes per second throughput. This is kind of theoretical throughput of the Azure blob storage. So if you get higher number, that means what Microsoft invested some time and made it better, but don't expect too much. So you will not see numbers like typical for on-premise configuration, 200 megabytes per second, 300 and higher. Forget about that. SQL.io can help you understand your disk configuration throughput. We talked about what we have options, how we can scale it, right? And you may use different tools for loading data. You may write your own data loading part or application which will be moving data from whatever to the data warehouse. Measure throughput of this application, because simply the stuff like a data connection driver which you invented yourself or you have taken from open source or from other vendor may have significant, may become significant bottleneck for you. So like I/O subsystem shows one number, your physical hardware where you're trying to test it is also very good, but you see 10 megabytes per second. Where it's coming from, often from the connection driver. So you need to think if it's your bottleneck and then replace it with something that performs better. Now, example here, how I tricked a little bit the speed of getting data, reading data out of the disk. So I used VM in the Azure, which is close to my final data warehouse. And I told you I wanted to load data from the flat file. But one thing came to my mind. Data disk, again, is a blob. Blob has a limit of the 60 megabytes per second. So if I want to go higher and read data faster out of the data source, I need to use several drives. So I basically copied the same file to 2 physical disks, and so I increased the throughput into 120 megabytes per second. Then what I did, so basically the stream was split into 4 smaller streams, and I applied the modular operation. So basically everything which equals modulo 0 out of 8 goes in one stream, one to another stream, etc. And I load it into the same destination actually, so into the line item table. The second was continuum from the stream 4, 5, 6, and 7. So this is why I did it, because I wanted all CPUs getting busy on the receiving side with writing data to the disk. And if you got 8 CPUs, you want them all to get busy. So, started process, what I see, 3 megabytes per second per disk. We've been talking about 120, it's a little lower, right? So overall throughput was around like 22 megabytes per second. Question comes how to troubleshoot it. Where I need to look at and understand what the problem is, what the bottleneck is. And Azure system, Azure VM, will have exactly the same stuff to analyze your data. Like you go and look at the DMV, like in this particular case I look, usually you start with sysdm OS wait stats and exec query request. So when you execute OS wait stats, you see the top waits with your system waiting on. Exec request shows you what each query what runs on your system is waiting on. And you see a lot of stuff like async network I/O, SAS, scheduler, yield, and etc. One thing to understand about Azure, this is commodity hardware. The CPU performance is not the best in the industry, right? And the I/O system, as we discussed, is also somehow different from the on-premise configuration. So therefore, often, if you analyze what happens to the system in the Azure VM, you will see typically network I/O problem, you will see disk I/O problem in the CPU. It always will be at the top of your weights. However, if you tune the system, I think what you want to analyze is really to understand what the difference before and after you did your tuning. You will still have tops related to I/O and tops related to CPU, but what you really care about the quantity. If it gets less, then you did something good. If it's increased, then you did something wrong for your system. And now getting concrete. So options, how can we load the data? Not that many options. Heap table compressed, and table with the index. So knowing from the loading performance guide, heap option is the best option. So I loaded 780 million rows. It's about like 200 gigabytes within 1 hour, which is, I think, for the cloud environment is pretty much okay, even great, right? Then switching to the compressed version, I see immediately what my loading time increased 5 times. This is obvious for the cloud environment, so for multi-tenant environment, if something gets slower, it gets multiple times slower comparable to on-premise configuration. So you need to understand whether this difference in loading speed will be okay for you or not, and then decide what is the best option for it. So comparing loading data into heap and the clustered index, interestingly enough, the discrepancy was not that bad. So we got 20 extra minutes for loading exactly the same amount of data. Where you get penalty from? Of course, from the sort operation. Because once you load data in the clustered index, it will be sorted, and it very often impacts 10 dB. Therefore, the best practice, guys, the same as in the fast-track reference architecture, 10 dB should be spread exactly the same way over the disk drives as a user database. So use the option to improve performance here. Now, if you talk about query performance, there are a few options as well. You have heap table, assuming what you will be dealing with big scans. You can build primary key or clustered index on the table. And of course, you can apply compression to reduce. We are dealing with a situation where I/O is our major bottleneck. So compression actually for the query performance can do really good stuff. So what I did, I started this HammerDB and started hammering the database with one of those 22 queries and trying to understand the average query performance here. And so you see the red lines, it is heap table. And you see the query number 9, that was my favorite one. The execution time took over 10,000 seconds. So I do not want to calculate it in hours, but I took like whole working day to get this query completed. So it's more than 6 hours, I think. So heap for some of the queries might not be the best choice. That's what you need to keep in mind, right? Clustered index, though, gives significant performance improvement for the query execution. Clustered index compressed, even better. So we are getting to the realistic numbers, as I told you about, like my expectation from the system. I started getting query responding in the seconds instead of minutes and hours. However, this might be for some of the cases okay, like if you deal in the range like of first up to 8th TPCH kind of queries, or on the left side from me, right? You may say, oh guys, you know, it might be good, so therefore I will move my data warehouse in the cloud, except you have the stuff like query number 9 does, right? Can I get better? This is the question. Of course you can get better. You can apply non-clustered column store index on the table. The restriction here, so the difference, I tested it and we'll be talking a little bit kind of not very directly about that in the next slides. I applied it and the performance just was amazing. The difference was so big with this classical way of using indices, but it was really a great option. The only thing about SQL Server 2012 and the non-clustered column store indices is, once you build this non-clustered column store index on the table, it is kind of archived table. You cannot update it anymore. So if you want to update it, you need to drop index and recreate it. So you may say it's okay, it doesn't take too much time, but then you need to add it in your operational procedures. So drop in index, add in data, and recreate an index. It impacts actually the speed, how fast can you get data out of your table. So how fast can end users see it. Okay, so, but what is the other option we have? And here we come, SQL Server 2014. So the question was, there are a few new stuff coming in SQL Server 2014 which can dramatically change the picture what we saw before, right? And if you talk about SQL Server 2014 new functionalities, there are two significant things in my opinion, especially considering the utilization of this code in the cloud. First of all, in comparison to the classical SQL Server, you can create your data disk or data files directly in the blob storage. So instead of pointing to the drive, you can point to URL. So this might be interesting for particular cases. I have tested it with my TPCH table. I haven't seen significant performance improvements of this configuration. However, I haven't seen any degradation. So the performance of the loading and performance of the reading data out of this configuration was exactly the same as if we compare it to the classical approach. Another thing what comes interesting in the, actually before we go there was a lot of improvements in the non-clustered column store index performance in 2014, such as things like we've been talking about that if you do wrong estimates on the table, right? It can end up with what you will be loading in the query tree, way more rows in the data, and it will end up with table spill. So if you get more rows than you expected, the memory will not be expanded during the query time, right? So therefore all the extra rows will be spilled in 10 GB. So this, if you have problems with I/O, will significantly impact the query performance. So, but it was also single-threaded operation before. In 2014, what they changed here, they made it as a cool. They made it batch operation, means that it's several streams, so it performs way faster than in 2012. And another new things which comes is updatable clustered column store index. So basically create clustered column store index and you can load data there. So what we have immediately tested, remember heap table versus clustered index table, 1 hour versus 1 hour 20. Loading in the clustered column store index, it took us 2 hours. It is some kind of performance degradation, we can say, but where it's coming from? Clustered column store index builds segments and it compresses this. So therefore, two operations happen in contrary to the writing data to the just regular index structure, right? So therefore, the I/O impact and the CPU impact. But if you look at the query performance, I intentionally created this table underneath it. It doesn't look very good now, but still, you see the best options from the previous test, clustered index and the compressed clustered index, they become not that attractive comparable to the performance of the queries with the clustered column store index. We get performance improvements up to 51 times. So between like 39, 50, 55, and etc. All across queries. So and they get queries executing like within 12 seconds, within 16 seconds versus like 700 seconds and etc. Great performance, I would say for many cases that might be acceptable SLA completely. And there was one outlier, it was query number 19, right over there. And execution took, I don't know why it shows here 100, it was actually, 1,000. Yeah, 1,000 to, it's missing 1 0, 1,000 seconds. I was really curious to see why is this happening. And exactly, interesting stuff. It's better to have some online connections. So the estimates what we are getting from reading data out of the clustered index scan versus the actual is very big. So we've got 1.3 million rows, but in fact we were reading more than 195 million rows, actually nearly entire fact table in the memory. Of course it was very expensive. So why was happening? Because of the statistics. So the filtering conditions were not very good on this query. So what you can do here, you can play around the options, like try, for example, and build filtered statistics for this particular query. Or another thing which I tested was, there was a best practice from the 2012. So in order to speed up or to improve the statistics and estimates there for situation here, build primary key on the table and non-updatable clustered column store index. And then performance become significantly better. Like it was even better than in the picture here. So like it was even better than the compressed clustered index. So therefore, with all this said, SQL Server 2014, even in the CTP2 quality, is way better than for the data warehousing in the cloud situation than if you compare it with SQL Server 2012. Of course, it will give you a lot of significant improvements on on-premise configuration as well, but I think with under certain SLAs, right, it might become the way how you want to build your data warehouse in the cloud. So the short summary is what the data warehouse in the cloud can give you. First of all, easy deployment through the gallery and the scripts. So easier getting the stuff available for you. As I mentioned already, you don't wait for the hardware to come into your infrastructure in a few minutes. If you have subscription, you created your environment, you can play with this already. Now, most of the best practices, except one which I've forgotten to mention, I'll tell about that in a second. Most of the best practices for loading data and for query performance are getting even more important in the data warehouse in the cloud because of the I/O and the CPU restrictions, right? So follow them. One of the best practices which is not considered there is called disk warm-up. The problem with this is following. Since we talked about that the disks are the blobs which is supposed to use as NTFS volumes, but in fact they are sitting in different rack, they are sitting in different different infrastructure which you connect over the network. This infrastructure also has some intelligence. Therefore, what it does, if some clients, let's say, not connecting to this, it maintains kind of hot top list, right? So for those who are constantly working with this rack or with this disk shelf, right? They are trying to keep the connections on the top, so that if you get I/O request, you get served immediately. If you're not contacting this system, you get flushed out of this cache, right? So therefore, what we found out, before you start accessing your disk, try to warm up it. Like create a dummy workload, which like SQL I/O, for example, would be a good example, which will be accessing your disk for a couple of minutes, like 15 minutes, 20 minutes, something like this. You will see significant difference as you start it cold and as the disk will be warmed up. So, and one of the reasons also for doing that, what we saw is actually what if you warm up your disk, your I/O response will become more or less flat. You will not have spikes like big latency, low latency. It will become more or less average, right? And yeah, one of the last stuff to mention, low TCO. The cost of the 8-core machine in the VM is way, way lower compared to having the same box in your on-premise configuration. Especially, what I was surprised to know, well, I'm a technical guy, I'm not responsible for licensing, I'm not trying to sell it to you, right? But the good thing about data warehouse in the cloud and based on IaaS is what you pay actually for amount of data what you are not reserved but what you used. So if you create, for example, the database, if you allocate for your database 16 drives, each drive can be up to 1 terabyte, so you basically can allocate 16 terabyte of data. But if you create a like 300 gigabyte database, you'll be paying for 300 gigabyte database, not for 16 terabytes. This is also a very nice option. If you buy 16 terabytes drive, it's cheap actually now. If you're not talking about high performance IO systems, right? So if you buy 16 terabyte drives, you pay for them, even if you're not using them, right? This is different with the Azure. And with all this said, I can just encourage looking into this option, trying to play with this. Let us know how you find it. It is applicable to your configuration, to your solutions, your experience, and I wish you having fun with playing with these images. Thanks.